Okay, we are going. Thank you everyone for joining us today. My name is Dione Mentis. If you haven't yet introduced yourself in the chat, please do and share a bit about why you are joining us today. Together with me today is some of the COMET organizers. We have Adam Buttrick from CDL, we have Juan Pablo Alperin from the Public Knowledge Project, and Maria Goad from DataSite. And they're going to be presenting with me today. Now, there's a section that is, of course, a presentation. We are sharing results of one of our projects, but this is not a webinar, this is a meeting. So we do encourage you to please keep the questions and comments going in the chat. And then we will open up the mics in the feedback and discussion section of this presentation. We'll be able to answer questions and have a deeper conversation on the project that we're discussing today. These meetings are happening every quarter. This is the first one for 2026, so welcome. It is being recorded, as you know, and we will share it via our newsletter and publish it on YouTube after the meeting. I'm going to start off with a brief introduction and recap to COMET. For those of you that are new, COMET is a community. It is everyone that is in the room today that has joined us, so thank you. And this group has come together to form a collaborative initiative to improve the quality of PID metadata. We're a diverse group with many different kinds of stakeholders and with different expertise. And some of what we will discuss today will be technical. That is the nature of improvement to metadata. These enrichment projects can be quite technical, but please don't worry. This is the right place. So long as you care about metadata quality, you're in the right place. We will aim to provide enough technical detail for those that are interested, but make sure that the information we share today is accessible and meaningful to the community as a whole. We've come together to focus on the quality of PID metadata. PID metadata being the backbone of scholarly communications. It gives us the opportunity to improve the quality and thereby improve the discoverability, the reporting on and the reuse of metadata, and ultimately, hopefully, to improve how that research is shared across the world. We've envisioned a space where valuable research information is de-siloed and shared with the community at large. And we're working towards a scenario where high quality PID enrichments can happen at scale. We've articulated this vision into a model, the COMET model, which we've described in 3 foundational principles. We're a diverse group with many stakeholders, and we all have a part to play in the collective stewardship of metadata quality. And we can enjoy in this collective benefit when we unlock the value of metadata that's held in separate places and bring that together and publish it in an open way according to FAIR principles. Just like any other community-led initiative, we operate transparently. We invite participation and feedback from this community, and we're also focused on meeting the needs of this group as has been expressed through the various forums that we've had. We've taken some time to dive deeper into the model, and we've broken it into these 6 elements. I'm not going to go through all of these now, but I encourage you to look at this link, which is on our website. It's on our blog post called The COMET Model, where we outline these different elements. For example, we have a focus on making sure that we're providing multiple reconciliation and integration pathways to get enrichments back into the authoritative metadata sources. And the approach that we've taken is really founded from a lot of deep discussion with the community. This started at two key conferences. There was the Force 11 conference and the Paris conference on open research. And at these conferences, the topic of community sources of metadata enrichment was ignited again. And this led to a task force phase where, over a number of months, about 80 or so people came together, where we convened listening sessions and focused on understanding the needs of this community and putting together ideas of how to meet those needs. This then culminated in a community call to action, which got really good support and allowed us to set up this pilot project phase, which we are in now. And in this phase, we are testing approaches to collaborative metadata through these targeted enrichment projects. These projects have been set up with specific goals. Firstly, we need to put the model into practice to show that it can work. It's been an opportunity to collaborate with community members on real world cases, which we've done in a number of the pilots that we've completed so far. And the experience that we're gaining in trying out different enrichment processes and focusing on different types of quality issues allows us to improve the framework and plan for success. Also, by looking at specific cases, such as affiliations and affiliations in preprints, which we'll focus on today, this allows us to diagnose and quantify the extent of the quality issues across the scholarly record. But we've also made sure that these pilots are very outcomes focused. So each pilot is delivering tangible results in the forms of enriched data sets that we've published openly and the enrichment processes themselves, which can be used going forward in a larger infrastructure that can unite the different processes in one place. Of course, all of this learning is leading to inform the future infrastructure needs and the operational needs of how this community effort can work together. We've been working on 7 enrichment projects. I'm not going to go through all of these today. Again, I point you to the enrichment project page on our website, where you'll find documentation that goes into the details of each project. As you can see, there's a strong focus on affiliations, which is intentional. We see that as a high impact field to focus on. And today's presentation is also focused on affiliations, particularly of parsing preprints. And with that, I am going to hand over to Adam Buttrick, who will be presenting the results from this pilot.
Thanks, Dione. Can you pull up my next slide?
Sure.
Hi, everyone. As Dione said, I'm Adam Buttrick, California Digital Library. Here today to talk to you about some pretty exciting work we've been doing to unlock metadata from preprints. Specifically, I want to walk everyone through how we trained a small, open, weight large language model that achieves state-of-the-art performance for extracting authors and affiliations from full text. The high-level takeaway here is that with this approach, we can now produce rich, open metadata at scale, but at greatly reduced expense, and achieve our goal of enabling direct improvements to persistent identifier metadata right at the source. Next slide, please. So before we get into all those details, kind of the how of it all, I want to walk through the why of this specific pilot. So we are really kind of undeniably in an era of rapid research dissemination where preprinting has become central to how science is produced. So I think we all know that preprinting rates have grown dramatically over the past few years, and it's now a first-class research output in many domains, being accelerated even further by things like major funders either encouraging or mandating preprint deposition. Closer to home, the work I'm presenting today is largely possible because advances in machine learning are disseminated exactly in this way, in exactly this forum. But at the same time, the kind of speed and openness of preprinting can come with a trade-off. In many cases, the metadata used to describe these works often lags behind the pace of that publication. Next slide, please. So why is this the case? Why do we have these metadata gaps? Well, first we know that historically the production of high quality persistent identifier metadata has required a great deal of expertise, manual review and correction, as well as the management of really complex data flows across systems. It's generally just kind of very resource intensive. It's not a one-time effort. And well-resourced publishers with the metric systems, they all spend significantly to achieve these outcomes. Although I think we all know more often than not, it's also the result of leveraging the labor of folks like us on the call. So leveraging the effort of the community. Um, and this is kind of changing a bit. Folks like Open Archive have been making some really great moves to kind of get preprint metadata up to a state that is equivalent to other forms of publication. But for a lot of preprint venues, by contrast, they often don't have access to that same level of expertise, community contributions, or just kind of a general extent of resources as those other players. And this is especially true when we consider the scale, of that backlog of works that would need to be more completely described. So we're talking millions of works, dating back to the 90s in some cases. Next slide, please. But this kind of really produces a real contradiction because there's this seismic change underway. Researchers are rapidly advancing science through the preprint ecosystem, while at the same time, the account of the associated impact is being understated because the metadata to support the analysis just isn't really where the community needs it to be. And even in the places where a proper description of this impact might kind of purport to exist, so we can think of closed bibliometric tools, we really have little visibility into how these accounts are produced, their correctness, or their underlying provenance. This latter point, of course, really is tremendously important for research assessment. So if I can kind of paraphrase a rallying cry of the Barcelona Declaration, how can we fairly and correctly evaluate the contributions of researchers and institutions if the underlying metadata is incomplete or the product of kind of black box closed systems? Next slide, please. So the answer to this call is, of course, to create the alternative. If we want to address these challenges of aligning what we're doing with how it is captured and described, we, meaning this community, have to take ownership of that work. We need to build for ourselves pathways and solutions that are truly open, comprehensible to us all, and that we can iterate upon and refine as needed so we're aligning our own activities with their description. Next slide. Lofty words and sentiments, but how do we turn them into action? Well, we organized COMET to provide a vehicle for just that, bringing together the community to open the way for direct improvements to persistent identifier metadata directly at their sources. So building on our prior work with both Archive and DataCite, where Archive registers their DOIs, we set ourselves kind of an ambitious goal. Let's try to bring the quality of affiliation metadata for Archive preprints up to the standard that researchers expect from traditional publishing venues and closed bibliometric tools. So we want institutions to be able to really see themselves reflected in that metadata by way of those affiliations being present. The ultimate goal then would also be to integrate this back into DataCite, with then this also kind of serving as a model for producing high quality author affiliation metadata for really any preprint menu or any publication where we have access to the full text. So we can think of all of the open access works that are in repositories, et cetera. Next slide, please. So ambitions, achieving those, always easier said than done. And the challenges here are actually quite different from our earlier work with Archive on preprint matching. So we did a whole community call about that. If you want context, you can go back and walk through. But in that case, we were working with structured metadata inputs and outputs. So linking essentially one form of an existing description to another. Here, the affiliation metadata is locked up in the PDFs themselves. So extracting this metadata itself is also not exactly straightforward. Instead, kind of requiring that we act on the whole document because its location varies quite a bit. It can span across multiple pages, be hidden in footnotes, or found only on the last page of the work. These are actually all places that I had not really encountered till we dived into this corpus, seeing, physics papers with lots of authors across multiple pages. Math papers tend to have the authors on the last pages. So you learn something by doing this. And to make things just a little bit more trickier for ourselves, there were no existing high quality data sets that we could use to benchmark our performance on this task of extracting authors and affiliations from the full text. Next slide, please. So that was the first thing we really had to tackle. We had to create this benchmark data set ourselves. So to do this, what we did is we extracted a random sample of over 2,000 works from all of archive, doing manual review and annotation, identifying author names and linking them to their affiliations, with this then proceeding through multiple rounds of human and automated corrections to kind of give us an appropriate ground truth. We have this now available actually as a fully open data set. You can share as follow on from the call. But the goal here is that everyone can then also use this data set to evaluate any method for extracting authors and affiliations from sources like archive and really have an empirical view of their performance. So I'm talking about what we did in our performance, but this data set is really a durable artifact that others can use to evaluate our own methods, others that people come up with, others that they might develop. Next slide. But so with this benchmark in hand, the next kind of natural step was to see how existing author affiliation extraction tools, specifically those developed by the community in open source fashion, perform against our benchmark to help kind of orient ourselves, kind of guide where we are with the work. So where we started was by assessing Grobid against our benchmark, as it's kind of a computationally efficient and among the most widely used tools for author affiliation extraction, including in infrastructures like OpenAlex. So if you don't know what Grobit is, not really a big deal. It's a tool for extracting all kinds of metadata from full text. But what we found in evaluating Grobit against our archive benchmark was that while it performed well on author extraction, so getting those author names out of the full text, it really underperformed on the affiliation extraction task, achieving only about 80% precision and 50% recall. It means it can only be about correctly get about 80% of names and can only find about half of them. And this was even when we used a fuzzy versus strict form of evaluation. So for our purposes of really trying to derive high quality institutional data, this was kind of deemed insufficient. Next slide. So as a new frame of reference, what we wanted to do was then look at structured extraction with kind of large closed models, the ones that everyone is familiar with. So, Anthropic's Claude, Gemini, those kind of things. Now, I want to be really kind of clear and explicit. Using closed models like this kind of runs counter to our core aim of building free, open source, and reproducible workflows. But these models kind of also represent the frontier of what's technically possible. So it's important to understand their performance, just kind of strictly as a benchmark for ourselves, so we can kind of see if we can achieve kind of a similar level. What we found is that while, yeah, they generally perform quite well on this kind of long context task, meaning we're giving the kind of full work as an input, using it at the scale of the archive corpus, which is almost 3 million works, is kind of prohibitively expensive, costing somewhere in the range of $60,000 to $100,000 at today's API prices. And really, beyond that cost, the approach produces no durable artifacts. So we have no reusable models, no reproducible workflows, making it kind of fundamentally unsustainable for doing any kind of ongoing metadata enrichment. Next slide. So given these results, kind of comparing the open and the closed, the approach we aligned on was to fine tune a small kind of open weight large language model specifically on our task. So getting those authors and affiliations out of archival text. The idea here was that a smaller kind of task-focused model could potentially match or approach the performance of these larger closed models while being more practical to deploy. So this would allow for kind of faster and more memory efficient kind of inference on that long context, meaning that we're not taking up kind of computational resources with the model itself, and we have more room to kind of push throughput through the model. So because we have to work with these kind of large full document inputs. Next slide. So as Diony mentioned, this is where it gets a little bit technical, but stick with me because part of what we're trying really to do with COMET is show that this work isn't magic. We really want to demystify it. And building these tools ourselves is kind of really genuinely kind of in reach of the community. Okay, so that all being said, after kind of exploring various training methods, where we ultimately arrived at was using supervised fine tuning combined with off policy distillation. Fancy terms. In more basic ones, what this means is we took a very large open weights teacher model and prompted it to produce author affiliation extractions along with its reasoning traces. So you can think of these as kind of a scratch pad of the thought process that big model used to arrive at the correct answer, kind of showing its work. We then retained only those outputs from this large teacher model where it produced the correct answer. So we could use these as high quality examples to train our smaller student model to perform the same task. Next slide. So specifically for this training, what we also did is to order the examples according to a curriculum, much like how you would design a course for a human learner. So using the measure at the top here, we identify how surprising each correct author affiliation extraction example is from the large model, from that the large model produced, how surprising it was for that smaller student model. We then conduct training by starting with easier examples, so the ones the student model found least surprising, and then gradually introduce harder ones as it progressed, interspersing both easy and hard examples in later rounds to reinforce what it learned. So this is exactly, how people learn. We start out with things that are basic, we move to things that are more complex, and then we use, kind of interspersed examples to get better over time. Next slide. So using this approach, we tested a number of open weight kind of teacher-student model pairs. And the best result came from distilling an open source model called GLM 4.5 Air into a small student model, Quen 3.8b. So the resulting model achieves 97% precision, meaning when it extracts something, it's almost always correct, and 80% recall for authors. Um, and meaning it finds kind of the majority of what's there. For affiliations, we hit 91% precision and 81% recall. So this performance is just kind of a stone's throw away from closed model performance in our experience, but now kind of in a model in an artifact that the community can actually use. Next slide. So with these results in hand, what we did is we conducted a large scale kind of inference on a markdown conversion of the full archive corpus as of 2025. So that's about 2.8 million works. And from these, we extracted 10.3 million author entries and 12.1 million affiliation entries. So even better, using a great new affiliation matching strategy designed by Crossref's Director of Technology, Dominika Tkaczyk, we also matched all of those extracted affiliations to about 9.2 million of them to ROR IDs. So that's about 76% of the total. And we know kind of from previous testing on this matching strategy that can empirically perform at about 97% precision. So highly precise matches to those affiliations. But these two interventions, when combined with the dataset metadata, really kind of unlock enormous value. So for the first time, we have kind of truly open, reproducible impact tracking for all of archive. So next slide. But let's not take my word for it. To demonstrate this, we put together a demo UI for everyone to model what that impact would look like for downstream consumers of these enriched kind of DataCite metadata records. Again, to showcase that world that we want to see, where preprint metadata is as well described as other publications, and kind of everyone's work is reflected therein. So let me pull this up. Okay, are we seeing?
Yep.
Okay, so we're not really in the business of building UIs, but if we sent everyone on the call a big JSON file and said, "Hey, it's great, look at all of these authors' affiliations," I don't think that would have the same impact. So we put together this little demo. So again, this is all of our data, all of our archive author affiliation data now integrated with the DataCite records such that it's fully searchable across all aspects of the records. So now we can see, for example, the top kind of institutional contributors to archive. Again, this is by way of those affiliations being reconciled to the corresponding WAR IDs. But we can also do fun things like do searches for various organizations. So we can look at UC Santa Barbara. Oops. Publications that were made in 2025. And because it's me, we'll also do this subject as machine learning. Okay, so we can see in 2025, there are 95 works that have the subject tag of machine learning that were published by UC Santa Barbara. If we open up one of these works, we can see, those kind of corresponding subject tags, as well as all of the institutions that are linked to it by way of these extracted affiliations over here. What we can also do now that we have an institutional view into archive is to look at kind of UC Santa Barbara's aggregate contributions to archive itself, see things like who are their top kind of collaborators over the years, breaking this down by country. So let's see who in Brazil, if anyone has collaborated with UC Santa Barbara. So yeah, these are Universidade de São Paulo is obviously a big university in Brazil, so no surprise to see them there. But we can also do cool things like break this down by subject. So specifically in artificial intelligence, oh, none there. Let's look at machine learning, see if we can pull some up. So we have one example of a co-authored work between Santa Barbara and this university in Brazil, which we can also pull up and see. So that's very cool. Um, and we can also just kind of generate aggregate statistics, kind of like we had on that front page right there, about kind of, again, contributions to archive. Seeing, kind of across all of archive, who are the kind of dominant players by country. So we can look at Belgium, for example, and see, and then further filter by subject. So I know there's a lot of physics work, so let's pick a physics category. Uh, Quantum algebra, let's say astrophysics. So we can see here are the top kind of astrophysics contributing institutions. So I think very cool. And again, this is really the ideal world that we want to see, where now all of this data is flowing out. And really all this is DataCite record plus our author affiliations and ROR IDs. I'm happy to, if there's other folks on the call who want to see other searches, happy to run those too. But otherwise we can move over to answering some questions.
Okay, so I am going to then open the mic in that case so that everyone can unmute themselves. And I'm not sure it's necessary for me to share my screen. Juan Pablo is going
No,
to
I don't think so.
take care of
Yeah, I have
the
the.
discussion section.
So
Great,
thanks,
go for
so
it.
thanks, well, Dianya for setting us up, and Adam for presenting and bringing all that forward. I have the easy job of just calling on the room for questions and to see a little bit sort of what are you all thinking? What are the questions that come to mind? What are the things that you want to dive a little bit deeper into, whether they be on the technical side or whether they be on a more sort of whole on where we're at with Comet or with this pilot in particular. So let me just kind of generally open it up and see if there is any questions from the crowd. By all means, I think you should have the ability to unmute and come on camera if you wish, or not, or if you would rather put your question in the chat, I'm happy to read it out for you. So let's.
So yeah, we have two. The first one was from Eric, and he said that I believe supporting institutions get an annual report from Archive outlining how many of their authors contributed to that work. Have you tested against these reports? No, but we're going to. I think previously this data was coming from a relationship that they had with Scopus, and now they're doing an open thing internally. So we do want to look at that data and see how it aligns with our accounts. So we have did some baseline comparisons against other open infrastructures, which guided our kind of initial desire to tackle this work. And we found that, really they're not archive preprints aren't represented at the same level as other works, but we do need to do that institutional reporting comparison. And then we also had a question from Vesela. What does it mean that the student model was surprised? So it means essentially that kind of equation that was at the top of the panel. It's a measure of next token prediction. So it's saying, given this input, and you're kind of asking me to extract the affiliation from it, what is the probability that I would respond with this answer as opposed to other answers? So when the smaller model, when it's kind of like a lower probability, that really means that the smaller model is surprised.
Yeah, there is well a comment from Allison that he may have another data set that we might want to use, and so that's something that we can if
Yeah.
you want to share some details, Allison, by all means, I'll let we'll sort of we don't but if you so but otherwise we can certainly get in touch and we can talk a little bit about what the opportunities
Yes,
there.
whenever you want.
Perfect. Great. And then there is a good question from Thomas as well as they say maybe missed this info, but will the affiliations data we've extracted be contributed back to archive? So really great question and showing a good understanding of the idea of the COMET model. So maybe Adam, you want to take that?
Yes. So I have a slide about this, but I wanted to actually I was talking for a long time, so I wanted to give folks a chance to jump in. But DataCite is building a metadata layer that will allow these kind of enrichments to sit alongside members submitted data such that we actually can fold this back into the kind of into DataSet itself and all downstream kind of consumers or harvesters of the DataSet metadata. We, of course, obviously also have the open metadata fully available, so anyone can make use of it now. They don't have to wait for that to be built.
Yeah, great. And then there is a question from Maria, which is actually one of the questions we'd already been kind of thinking about, but I'll pose it here
Yeah.
as she's asked it. Is it possible to test against the public versions when they're available? And so, we know that we have these data sets that have been already published, and we've been working on one as one of our pilot projects of matching up preprint to the published versions. And so that means that, authors in one of the preprint are going to be the same, or at least almost in all cases, the same as in the published versions. And so, what can we do with that, Adam, in terms of testing, as Maria asks, or just in terms of also the possibilities of enriching also the published data if it's missing some affiliations?
Yeah, absolutely. So archive metadata does contain kind of in itself, meaning directly from archive, links to published works in some cases that are contributed through some kind of publisher process. But then also remember back over the summer, we did a project where we did preprint matching for archive, where we found published forms of those works. So now between those two things, we actually have, quite an extensive data set of links between archive preprints and their published works. So we would like to do that analysis of saying, okay, but based on these links, how correct are the extractions? Where are their differences? Does the affiliation metadata map well between the two things? So in cases where there are existing asserted affiliations on the published forms, does that match was extracted from the archive preprint? If there's a discrepancy, why is it? Sometimes authors' affiliations change in between preprint and published forms. But yeah, it does, as Juan Pablo also mentioned, give us the opportunity to say like, hey, if we know these links and the kind of general analysis supports making those kind of assertions, we could push them up to the published forms as well. And then I think Maria wants to also
Yeah, I
ask
just
a
saw you,
follow.
Maria. You have your hand up, so by all means,
Yeah, no, I just thank you so much. I mean, it was a really wonderful presentation and so great to see the enrichment that's going on. I was also thinking that very few publishers at the moment collect ROR IDs. And so
Mhm.
not only is it possible to enrich preprints with the publisher metadata, but it's also possible to enrich publisher metadata with now an amazing match made for the preprint. So that is really cool in both directions.
Yeah, I like that everyone on this call is anticipating all of the things that we want to do. So we are actually working on that process of taking all of the existing affiliation assertions and sources like DataCite, Crossref, OpenAlex, and then affiliations that we also extract from full text, matching all of those to ROR IDs, and then using that as kind of a unified kind of data set or representation of affiliation ROR ID pairs, such that when those affiliations get reasserted, we can just leverage those existing assignments. The new matching strategy that was developed by Crossref is very, very computationally efficient. So we can actually do this at the scale of ROR data being updated. So ROR data is updated about every 2 weeks. Just to give one example, I can match all of the affiliations that are existing kind of in DataSite at the moment, meaning unique affiliations, in about 3 hours. So if we're talking everything that's in, DataSite, Crossref, OpenAlex, unique affiliations, I would say it would take less than a day for that job to run and match all of those. So really, we have a lot of opportunity there.
uh, great.
Um,
There's a
Cameron had a
question from
question.
Cameron in the chat, but he's also got his hand up. So,
Oh,
Cameron,
okay.
I'll
Yeah.
let you unmute yourself and jump on, and you can ask your own question from that
Yeah,
very futuristic looking room where you're.
yep, absolutely. Don't let me tell. No, I'll tell that story some other time. Thanks for the work. It's really, really exciting stuff. I guess so. The question I asked in the chat, I'll get to in the second bit. I guess I really pin you to the wall on what your precision and recall criteria are. So you're extracting the affiliations.
Hmm.
So by that you mean the string that's
Correct.
finally a single affiliation. So that then leads to the question I asked in the chat, which is the France question with their complicated multi-organizational nightmares, and whether there's a way to sort of also addressing, I think, Jeroen's question, presumably that 20% we're not getting so far is systematically maybe French, possibly Latin American, complicated cases which are hard to tease apart. So I guess I'm really asking the question, both what's the way forward, but what's the what are our opportunities for doing validation in differential buckets along the way?
Yeah, so great question. So when we did evaluation, we actually, so when I talked about Grobit, I talked about how we had a strict versus fuzzy benchmark. So what we actually did is do a very strict benchmark where we said like it has to be the absolute exact string that occurs in the PDF. This benchmark is actually kind of problematic because the visual representation of text as it's actually embedded in a PDF are not the same thing because PDFs are just a delightful rat's nest of all kinds of buried things. But then also a fuzzy kind of measure where we compare essentially a normalized form of the affiliation strings where we don't really take into account things like case differentiation or kind of trivial punctuation differences and things like that. Because various forms of markdown conversion can also introduce some minor discrepancies, and it's very hard to parse out whether that's coming from the PDF or the conversion process and things like that. So within kind of very reasonable kind of edit distance thresholds, so I think we used about 95% similarity for the normalized measure. Are they the same? The question of like that recall gap and how we would close it, yeah, there's lots of opportunities to explore there. So first off, we already know actually from experimental testing that some of that recall gap can be recovered by a higher fidelity markdown conversion of the PDF. So we know how to produce that, but it's very expensive to do it essentially. So we can use like a vision language model and we can run it through and we can produce it, but it just takes a lot of time, a lot of cost. So, we have to do kind of a trade-off analysis of like, if we run all of archive through this, how much would it cost, versus if we do kind of other recall improvements, can we pick those up? Second, you're correct that there are complex cases. I was actually surprised looking at the archive data, like how complex the representation of some affiliations can be. Again, these are often author-generated works, so they don't conform to consistent standards of representation that we might see in publications. For physics papers, in some cases, there can literally be listed hundreds of authors and affiliations. I was actually surprised at how well the model was able to do for some of those cases, although obviously when you get into the hundreds of things, its ability to reason and disambiguate kind of falls down. That being said, those cases of really complex affiliations were in our training data and then also in the test benchmark set. So we can isolate those cases or produce new cases to kind of improve it. So yeah, we know kind of the path forward on a few recall gains. There is probably kind of some fundamental limits to what we can achieve without pushing down one or the other. So precision and recall have this trade-off dynamic where you can either get the most precise representation of the string but get less strings, or you get more strings but then they're incorrectly associated with it. The last thing I'll say on this is that we did take into account, though, for precision recall when there were multiple affiliations asserted for a given author. So, for example, if the model there was two affiliations for an author, we only extracted one, it's penalized in the benchmark on that basis.
Great. And so I'll just check in with Jerome if I think that got to answering your question, but if you feel like it hasn't and you want to follow up, by all means, I'll just give you a chance to, if you want to unmute and jump in if you got a follow up. And if not, I'll turn to the room before I continue on the questions that are in the chat. So Babesh, I see your hand next. So if you want to jump on, by all means, good to see you.
Yeah. Hi, everyone.
Hey,
Wonderful.
Babesh.
Hi, Adam. Wonderful work as always, Adam and team. I got chills looking at the results, and then if it wasn't enough, you brought the UI, and I was like, oh, it's killing me. I was really surprised to hear that. I never used the archive API, but they don't have the affiliation exposed as a structured metadata. And not that I have trust issues, I was just messing around on the site and I verified that, yeah, they don't have that. And so it was very surprising. And from the previous questions, I heard that, hey, there's maybe a plan to share some of your kind of metadata affiliation you've extracted back with them. But is there a plan to kind of not just for archive, but others to have some best practices and say, hey, you should be exposing the affiliation already in your API and not others having to do all of this heavy lifting so that in the future, maybe all of that is done. So is this part of this task force to also maybe have some best practices for because there's new preprint server popping up like every other week or something. So maybe they'll kind of the problem will keep going on, and kind of how many will we be working with and so on. So is there a plan or not yet to maybe have some best practices and have everyone maybe collect the right info, including ROR, but also expose them properly for machine usability?
Yeah, I think that would be a great thing for like us as a community to take on. For like this pilot project, we're kind of more focused on what has always been perceived as the intractable problem, because it's kind of like, yes, it would be great if there are affiliations for archive, but there's 3 million works, and you know how complicated it is to mine the PDF for 3 million works? And I'm sure this is actually the same is true for other long kind of standing preprint. And I think actually the inertia around that problem kind of prevents forward momentum on that future kind of work as well. This being said, I think I mentioned briefly like Open Archive, who is now doing this in the context of bioRxiv and medRxiv, is actually starting to collect and expose all of that data, do things like preemptive capturing of data repository links as well to preprints. So they're really kind of like first-class research outputs in the way that we would traditionally think of from other publishing venues. But if folks are interested in taking up that work and saying, here's an example of how we did this historically, if you're doing this historically, now is also a great time to assess how you could do this, kind of in the way that we would like. Here's some examples, here's some expectations, and really define those for then preprint service to adopt. So yeah, I think there's tons of opportunities to do that.
Great. And then I see Francis, you've actually got the next question in the chat and you're the next hand. So that doubly it's your turn.
Thanks very much. I'm just, wow. I think it's amazing what you guys have done. It's, and I actually think the method is the most interesting, actually, because you have really, and you not only, you have the method, but now you also have the proof of concept in a very large scale area. It's just amazing. By the way, you have to keep it very simple for me. I was trained in traditional European philosophy, so keep this stuff very simple for me. I had a very basic question that myself I don't even understand too much, but does this line up with COR Notify? Can that be used within the same framework as COR Notify? And then I had another question too. Yeah.
Sure. I don't know enough about the specificities of COR Notify to really answer that. I'm happy to, I know that you do a lot of work with them, so we can connect and kind of figure that out. But to the extent that the data is integrated with DataCite and COR Notify kind of leverages that or tracks that, or they want to integrate any of our data, they can to make this kind of institutional connections, because it's all fully open, it's all completely free, it's CC0, there's no restraints on it.
Yeah, that was sort of my other question. Can we integrate this into other platforms more or less like that? Which, yeah, it's totally unfair to you guys who did all the work, but we like to steal as much as we can in life. But coming back to this is yesterday we had a meeting, actually a very interesting meeting with 3 different groups. One, I'm with the COARA, the Coalition for Advancing Research Assessment, and we have a working group on research ethics, but also on AI and data within this. And we're supposed to build a tool for doing research assessment. And of course, we need to bring the artifacts into the tool and need this metadata to do it at least. And we had a meeting actually yesterday with 3 different groups that already have started to build platforms, with quite different ones, really interesting ones. And also we think about doing a European project on it. But it would be, so this is, if we're going to have a tool for research assessment, we have to be able to get all of these different artifacts referenced in them and somehow built in so that there can be some evaluation and some kind of preliminary overview and things like that. So that's why I came here. I mean, because when I saw your email, I was like blown away. And I just think that if we can build this into a research assessment system, and we can do it also with a kind of feedback flow as well, which I think is really important as well. Because if I understand your model correctly, you can select whichever metadata you want. and then train, have the teacher train the student on it, and you're in, and you can select whichever data sets you want as well. So yeah, this has legs, I think. Thanks very much. Yeah.
Yeah, thanks. Yeah, so yeah, our goal is actually, this is another case of folks anticipating things that I would have said, so I love to hear it. But our goal is that, yeah, we'll expose all of this data. It's automatically generated data from a model. That model will do things wrong. We can get feedback on what the model has done wrong, and then use that to refine our training processes. So sometimes that means getting more training data. Sometimes that means correcting things like the variety assignments. But yeah, so that it's self-improving. But also because the model is it's a small artifact. I think it's, it's an 8 billion parameter model. So, other folks can also do their own experiments with it and say, oh, if we actually trained it in this way, or we did it in this other way, does it produce this other outcome that we want? So yeah, both of those things are opportunities. We have a lot of questions in the chat, and we have
Yeah.
folks raising their
Well,
hands.
yeah. So let's keep it. I was just about to say let's keep it moving. First, there's a couple of comments from Simone at RD, essentially saying, from the work that they've been doing, essentially another opportunity for a training data set. I don't think that there's a particular question there, but yes, Simone would be more than happy to connect. And then there was another, and then Allison earlier also sort of saying, I may have another training data set. And of course, these models this is one particular pilot. We're proving out that they could be done, and they could be done at scale. But of course, this is now something that could be extended out to different corpora, both for training and also for applying some of the model. And then that needs to be tested out, whether the same model, how well does it work
Yeah.
on corpora that are different than the one that we train on. And so these are all things that are sort of on our mind, and we certainly want to connect with folks that have these things, and also want to encourage people that you can also start playing around and trying to do some of these things yourself if you've got the capacity to do that, and connect with us there. Anyway, let me stop rambling because there are more questions in the chat. And actually, let's go to Bianca, guys. I know lots of folks will want to hear her question.
Always.
Yeah, thanks a lot for that introduction. And thanks a lot for this work and presenting it. It's really great. I actually want to cycle back on what Thomas and Bhavesh also mentioned we talk a lot about ways that these data can be used going forward. I wonder, have you had discussions with Archive themselves about this data? And because I know they don't expose it, they have been using affiliation metadata as a sort of incentive for their members, so they're keeping this closed. What's their
Yeah.
any idea about their relation, their feelings about this, their plans going forward?
Yeah, so we've been talking to folks at Archive. Archive, as I think lots of folks know on the call, has been doing a lot of work to re-engineer their platform relative to some grant funding that they have. So that's their kind of primary focus right now. I haven't really heard anything in terms of like objection about us producing this data. They've never at any point been like, no, don't do this or anything. They've been excited that we can actually produce some of this data. Yeah, I think we have to kind of see how to best move it forward, because there is some consideration and discussion, like on the data side, how members want this data integrated. And so, we're really trying to reflect kind of community desires around, yes, it needs to be there, but also, like members have their own considerations about what they want represented relative to the performance benchmarks that we talk. So maybe there's a higher threshold that needs to be in place or something like that. But that doesn't prevent us from kind of moving in the direction of the world that we want to see. So what I would say is that, yeah, there's the archive by way of really making the full text available. So for those who don't know, you can go and download all of archive yourself. It's served via a Kaggle data set. That essentially already makes it so you can derive all of the affiliations. And they are doing some of this work internally as well to look at how they can model the process, but they said that they might be interested in simply just leveraging ours.
And maybe can I build on that? One short
Sure, go
question.
ahead.
Yes.
For DataCite, you mentioned that you will expand. I think that the whole idea of COMET to have it as sort of a parallel to DataCite with the enriched ones. With this one, is DataCite also intentioning to really integrate it in DataCite, or would you depend on Archive to do that?
That's a good question. I think that's a discussion that has to happen between DataCite, Archive, COMET. I don't know, Maria, do you want to speak to that at all?
Yeah, thanks, Bianca. Thanks, Adam. Thanks, everyone. It's awesome to hear all this enthusiasm and yeah, people getting chills. Always something we want to we want to experience on a Zoom call. Yeah, I think from DataCite perspective, there's a lot of really exciting and important considerations that we're working through with members and collaborators like Archive, with collaborating initiatives like COMET. This why we're really engaged in this. I also posted in the chat. We're trying to source different comments and inputs from across the community about specific approaches in terms of DataCite API representations. So it's an active conversation on many levels right now as we're finding a way forward that makes sense for DataCite and our community and broader network of collaborators. So please contribute to the discussion, and we'll continue chatting about it as this work continues to develop.
Yeah, I'm actually going to link a DataCite discussion issue in the chat if folks
I
want to
already
provide some feedback.
did.
Oh, you did?
Yeah.
Okay. Sorry.
But thank you, Adam.
Yeah.
Great. Thanks, Maria.
Okay, I don't see any other specific questions in the chat. There was a nice resource linked by Katie, but I didn't see that there was a question there, Katie. So if there is something that you want to ask or point out alongside that, by all means.
My question was just whether there's any plans to do further testing with other preprint servers. Yeah, I can see now, I'm like poking around a little bit more and I'm seeing that there are reasons why DataCite objects are sort of the focus of the project, but just wondering if there's any plans to take it further.
Yeah,
Also,
absolutely. Good.
I'll just say I'm happy to facilitate any relationships with any of the preprint servers, given that they do seem to pop up every 5 minutes, but happy to connect you.
Yeah, absolutely. We would like to do some additional kind of testing and performance on other preprint servers. So we know that there are some that actually expose affiliation metadata, which provides us with an actual benchmark. So for Archive, I talked about how we didn't have a benchmark, but there are preprint ones who are doing a good job. So that might be a starting point for us to do some assessment. In some cases, they don't have affiliation data for some subsection of their historic backlog. So yeah, definitely looking for opportunities to extend. There's nothing about the specific method that limits it to being applied in Archive. The only thing that I would say is a little bit of a consideration is that the format of Archive preprints, because they're generated in LaTeX and they can be really diverse, might bias the model in certain ways for other preprint servers that have a more kind of standard structure, such that if we train something that was kind of more specific to that task, it could perform better.
Okay, I think because we've got about 5 minutes left for the end of the hour, and we just want to point people to next steps to give you some information about the next community call. So I'm going to turn it back to Dione. We'll close out the questions, but let me just say, wow, it was like doing this job of facilitating these questions. It was super easy. Loved seeing all of the enthusiasm, the excitement that people have, and the questions, like really good questions, like as Adam said, sort of anticipating things that we've been thinking about, things that we thought warranted a little bit more conversation. And so just really wonderful to see this community sort of coming together with like this right mindset around like really seeing what the opportunities and what this opens up. So and Dione, let me turn it back to you for next steps and giving people a way to stay connected.
Thanks, Juan. We have a few moments left. Adam, I think we've covered everything on your next step slide in the discussion. Is there anything you want to add here?
No, I just wanted to be proof that folks on the call were anticipating things that I was about to talk about, which is amazing.
Great. Okay. So we've had our discussion. Thank you so much, everyone. There was a lot of information in the chat. We will save that and come back to all those ideas. Just very briefly to find out how you can get more involved. Obviously, the community, these meetings are central to the success of COMET, and we're so glad that we can have these conversations. We are having these, as I said, about once a quarter, but there are many other ways that you can get involved. So we have 3 pilots still in progress. These are all documented on our website. Jump into that, ask questions, see if there's any space that is related to what you're doing and get involved. We also are publishing the enriched data sets. You're welcome to take a look at those, use them if you have the capacity, give us feedback on what's there. We're also completely open to receiving curated metadata processes. So while we're developing some processes ourselves, we know that in the community there are a lot of other examples of work being done, and we very much want to bring those together in a united space. We have only so much capacity during this pilot phase, but there's a form on our website that will lead you to filling in information about either the curated metadata that you have or an enrichment process that you're already using. And that will then give us the opportunity to understand what you're working on and come back to it at a later stage. You can also please keep informed by joining up on our newsletter. Again, that's on our website. And you can follow COMET's activities on the various platforms. We are publishing data sets on Hugging Face. Most of our code is in GitLab. We're putting these meetings and some other video content on YouTube, and we're on LinkedIn and Blue Sky. All of this, if you go to the Join Us page, you will find all of the links to this information. And the next meeting is set. That's going to be on the 22nd of April. So if you scan that QR code, that will take you to the sign up for the next meeting, so you can save it in your calendar, and we really hope to see you there. So I'm going to stop sharing my screen and just say thank you again to everyone. And we hope to see you very soon. I'm going to make sure that I save the chat before I end this call, because last time I didn't get it. And please reach out to us and keep in touch. And thanks again, everyone.
Thanks so much.
Goodbye.
Thanks, everyone.
All right. Cheers.